Hello and welcome back to the Coded Rocket. Today, in this fascinating video, we'll be going to the basics of software engineering. This video will be part of a big series on software engineering and their basic concepts. So, without further ado, let's get started and dive deep in. In this lesson, we will be understanding the basic of software engineering. That gives rise to the question, what is software engineering? Software engineering is a discipline of computer science that involves the design, development, and maintenance of software systems. It focuses on applying engineering principles. Yes, we have to apply some engineering principles and practices to create high quality and efficient software that meet the user requirements. Software engineers use various tools, techniques, and methodologies to ensure the successful development and deployment of software products. Now, what is its importance? So software engineering is crucial because it helps in building reliable, scalable, and efficient software systems that can efficiently meet user requirements, can scale up to a big limit, and is reliable overall. It ensures that software projects are completed on time and within budget. Software engineering also helps in managing the complexity, the reducing the risks, and improving the overall quality of the software. Now, I want to make you familiar with a very important topic that we have in software engineering technique that we use, that we call the software development life cycle, or SDLC, which is a systematic approach to software development that consists of several phases, including requirement gathering, design, implementation, testing, deployment, and maintenance. So here we can see the first step is plan what software you want to make, then design it, then actually code it out and develop it, then test it several times, and finally deploy it. And then it turns into a rigorous process of, it turns into a cycle that goes on and on. Each phase had its own sets of activities and deliverables, ensuring that software is developed in a structured and organized manner, which is very important while doing software development and software engineering. SDLC also helps in managing the software development process and ensure that all the stakeholders are involved in each stage. So first, the initiation, which begins with a sponsor identified, basically planning everything up. Then system concept development. It defines the scope or boundary of the concepts within the software systems. Then you plan it. We develop a project management plan and other planning, resources and things. And we then look at the requirement analysis. We do requirement analysis, which is analyzing existing data and collecting new data to meet user requirements. Then we design it, develop it, then we do integration and testing to demonstrate it, implement it, and then we check, we maintain it, and deploy. Now, another thing that we also need in software engineering is agile software development, which is an iterative and incremental approach to software development. It emphasizes collaboration, flexibility, and adaptability, allowing teams to respond to changing user requirements and deliver value to customers quickly. Several agile methodologies exist, such as Scrum, Flights, and Kanban, which promote regular communication, continuous integration, and frequent feedback on the software. Now, another discipline that we have within software engineering is software requirements engineering, which is the process of electing, analyzing, documenting, and validating user requirements. Basically, adapting the software to the user requirements at each stage of the process and each new version and iteration of any software. It involves understanding the user needs, defining system functionality, and ensuring that the software meets the desired objectives. It also helps in establishing clear cut communication between stakeholders and guides the development process. Now, coming to some software design principles which provide guidelines for creating modular, maintainable, and reusable software systems. Okay, you don't need to understand what's modular right now, but later on we may go through it. Okay, there are principles such as solid, single responsibility, open close, risk of substitution, interface segregation, and dependency inversion help in achieving loose coupling, high cohesion, and extensibility. Design patterns such as factory, singleton, and observer provide proven solutions to common software design problems. Now, we also have software testing and quality assurance, which is a very crucial phase in software development that involves verifying and validating software against specified requirements that's already taken from the user or collected using pre-existing data. Now, it helps in identifying defects, ensuring the functionality, and improving the overall quality that we have a given software. Assurance activities such as code reviews, static analysis, and continuous integration complement testing efforts to deliver reliable software. And again, if you don't understand some of these terms here, you don't need to do know that for now. But if you just want to know, just drop a comment below and gonna go through that in a future video. Now, software will continuously, we have to maintain it and it will evolve. That's where we have the terminology of software maintenance and evolution, which by name it pretty clear what it does. So basically, it includes fixing, performance optimization, and feature enhancements, and it's very a long term management really of software. Now, let's go through a quiz to make sure we all have understood everything clearly. Just pause the video after each question before I tell you the answer. So, what is the main focus of software engineering? Pause the video. Okay, so the main focus of software engineering is applying engineering principles to create high quality software. Now, the second one, why is software engineering important? To build reliable and efficient software systems. Okay, now what is the purpose of the software development lifecycle? Of course, it's ensuring compatibility with different operating systems. Not really. Structured and organized software development process. And finally, what is the key characteristic of agile software development? Flexibility and adaptability to changing requirements. Now we have what is the purpose of software testing and software development? It's of course going to be verifying and validating software against requirements. And that's it for today's video. If you like the video, just like this, smash that like button, turn on the notification bells, subscribe, and comment. Thank you.